So here in this problem we are given that the volume of the house is 1200 meter cube, and there are two parts in the equation. In the A part we have to calculate the total mass of the air inside the house when the temperature is 15 degrees Celsius. Now if we convert this thing into Kelvin, we have to add 273 to it and we'll get 288 Kelvin. Now we can assume the air to be an ideal gas and we can use ideal gas equation here. So PV is equals to nRT, where R is the universal gas constant and its value we have 8.314 joule over mole Kelvin, and pressure we can take to be as atmospheric pressure, which is 1.01 times 10 to the power 5 Pascal. Now we have all the values. We can plug it here to calculate the number of moles. From that we can calculate the mass of air. So pressure we have a 1.01 times 10 to the power 5, this is Pascal, multiplied with volume. So volume we have 1200 meter cube is equals to the number of moles we have to calculate, and R we know it is 8.314 joule over mole Kelvin, times the temperature is 288 Kelvin. So from here we'll get the number of moles as nearly 5.076 times 10 to the power 4 moles. Now next we should know the molecular weight of the air. Now we can take that inside air there is around 70% nitrogen and 30% oxygen. So average molecular weight would be around 29 gram per mole, or we can say 29 times 10 to the power 3 kg per mole. So from here we can calculate the number of the mass of air. So the mass of air is equal to number of moles multiplied with the molecular weight. So number of moles we have 5.07 times, this is 6 10 to the power 4 moles, multiplied with molecular weight we have 29 times 10 to the power minus 3 kg per mole. So from here we'll get the mass of air as nearly 1472 kg, which we can take approximated to 1500 kg. So this is the mass of the air inside the room. Now next we have to calculate the mass of the air that enters or leaves the house when the temperature is dropped. Now if the temperature is reduced, so let us take that around 30 Kelvin of the temperature inside the air is being reduced. So temperature in this case would become 258 Kelvin. Now corresponding to this value we have to calculate the number of moles inside the house. So we can use ideal gas equation here. So N is equals to PV over RT. So pressure we know it is 1.01 times 10 to the power 5 Pascal, multiplied with volume we have 1200 meter cube, divided by R is 8.314 joule per mole Kelvin, multiplied with temperature is 258 Kelvin. So from here we'll get the number of moles as 5.67 times 10 to the power 4 moles. Now the mass of air inside the room would be number of moles multiplied with molecular weight, and molecular weight we have 29 times 10 to the power minus 3 kg per mole. So from here we'll get the mass of air inside the house as 1643 kg. Now here we see that when the temperature is reduced, the mass of the air has been increased. That means mass would enter into the room and the value would be this value 1643 kg minus the initial value that was 1472 kg. So mass that entered the room is around 200 kg. So this is the answer for the B part. I hope you have understood the problem. Thank you.